This tutorials cover all the features of ASP.NET Mvc. Overview of ASP.NET. ASP. .NET is a free web framework for developing websites and web applications using HTML, CSS and JavaScript. Moreover, it is a technology for developing, deploying, and running web applications. ASP. .NET is a part of the Microsoft .NET framework, so all .NET framework features are available to ASP. .NET applications. That means, when you're developing ASP. .NET applications you have access to classes in the .NET framework. ASP. .NET web pages are simply pure text, like HTML files. ASP. .NET web pages are the main building block for application development. You can develop your applications in any language compatible with the Common Language Runtime, including Microsoft Visual Basic and C#. These languages enable you to develop ASP. .NET applications that benefit from the Common Language Runtime, type safety, inheritance, and so on. ASP. .NET incorporates all the important standards of our time, such as XML and SOAP, plus with the Do.NET and the Foundation class libraries. ASP. .NET is a web development platform, which provides a programming model, a comprehensive software infrastructure and various services required to build up robust web applications for PC, as well as mobile devices. ASP. .NET works on top of the HTTP protocol, and uses the HTTP commands and policies to set a browser-to-server bilateral communication and cooperation. ASP. .NET is a part of Microsoft .NET Platform. ASP. .NET applications are compiled codes, written using the extensible and reusable components or objects present in .NET Framework. These codes can use the entire hierarchy of classes in .NET Framework. The ASP. .NET application codes can be written in any of the following languages: C#, Visual Basic.NET, JavaScript, J#. ASP. .NET is used to produce interactive, data-driven web applications over the Internet. It consists of a large number of controls such as text boxes, buttons, and labels for assembling, configuring, and manipulating code to create HTML pages. Visual Studio. .NET is an excellent development tool for constructing ASP. .NET web applications. It provides all of the necessary tools and support for creating ASP. .NET web applications. ASP. .NET web applications are hosted by Internet Information Server, IIS, which accepts requests from clients and optionally authenticates them before passing the requests onto the web application. ASP. .NET Web Forms Model. ASP. .NET Web Forms extend the event-driven model of interaction to the web applications. The browser submits a web form to the web server and the server returns a full markup page or HTML page in response. All client-side user activities are forwarded to the server for stateful processing. The server processes the output of the client actions and triggers the reactions. Now, HTTP is a stateless protocol. ASP. .NET Framework helps in storing the information regarding the state of the application, which consists of page state, session state. The page state is the state of the client, that is, the content of various input fields in the web form. The session state is the collective information obtained from various pages the user visited and worked with, that is, the overall session state. To clear the concept, let us take an example of a shopping cart. User adds items to a shopping cart. Items are selected from a page, say the items page, and the total collected items and price are shown on a different page, say the cart page. Only HTTP cannot keep track of all the information coming from various pages. ASP. .NET session state and server-side infrastructure keeps track of the information collected globally over a session. The ASP. .NET Runtime carries the page state to and from the server across page requests while generating ASP. .NET Runtime codes, and incorporates the state of the server-side components in hidden fields. This way, the server becomes aware of the overall application state and operates in a two-tiered connected way. The Asp. Net Component Model. The Asp. Net Component Model provides various building blocks of Asp. Net pages. Basically, it is an object model, which describes server-side counterparts of almost all HTML elements or tags, such as form and input. Server controls, which help in developing complex user interface. For example, the calendar control or the grid view control. Asp. Net is a technology, which works on the Net framework that contains all web-related functionalities. The Net framework is made of an object-oriented hierarchy. An Asp. Net web application is made of pages. When a user requests an Asp. Net page, the AS delegates the processing of the page to the Asp. Net runtime system. The Asp. Net runtime transforms the Asp's page into an instance of a class, which inherits from the base class page of the Net framework. Therefore, each Asp. Net page is an object and all its components, that is, the server-side controls, are also objects. Understanding Net Framework 4.5 Architecture. .NET Framework is an integrated component of Windows operating system that supports development and execution of next-generation applications, Windows Store apps and services. .NET Framework 4.5 at its core consists of Common Language Runtime, CLR, Dynamic Language Runtime, DLR, Base Class Library, BCL, Portable Class Library, Parallel Extension and WinRT. With Net Framework 4.0 there are various new additions in BCL, which includes DLR, MEF, Parallel Extension, Entity Framework, WCF Data Services and ability to host Net 4 Runtime with Net 3.5, 3.0, 2.0 runtime side by side under the same hosting process. Components of Net Framework 4.5 Architecture. Common Language Runtime. This acts as the execution engine for the Net Framework. All Net programs executes under the supervision of CLR. Base Class Library. This is a library of functionalities which are available to all languages using the Net Framework. It consists of classes, interfaces of reusable types that integrates with CLR. Portable Class Library. The Portable Class Library project in Visual Studio 2012 allows you to develop and build managed assemblies that work on multiple Net Framework platforms. Using a Portable Class Library project, you choose the platforms, such as Windows Phone and Net for Windows Store apps, to target. Managed Extensibility Framework, MEF. MEF is a library for creating lightweight, extensible applications. It allows application developers to discover and use extensions with no configuration required. Dynamic Language Runtime. This provides the runtime environment for dynamic languages like Python etc. for executing under the full control of CLR. WinRT. WinRT or Windows Runtime APIs provides the user interface elements for building Windows Store apps, and provides access to Windows 8 or Windows RTOS features. WinRT supports development in C and other managed languages C# and VB.NET, as well as JavaScript and TypeScript. Asp.NET. This is used to build rich internet-based web application. Windows Store apps, Metro-style apps. A Windows Store app is a new type of application that runs on Windows 8 devices and can take advantage of new WinRT APIs. These can only be distributed in the Windows 8 Store. Desktop apps, Windows Forms. A Windows desktop app is traditional Windows Forms application with a new name. Software developed for Windows XP, Windows Vista and Windows 7 will be categorized as a Windows desktop app when running in Windows 8. Examples of Windows desktop apps are Microsoft Office Families products, Notepad etc. WPF. WPF is used to create applications with the rich user experience. It includes application UI, 2D graphics, 3D graphics and multimedia. It takes advantage of hardware acceleration of modern graphic cards. WPF makes the UI faster, scalable and resolution independent. Silverlight. This is a cross-browser web-based technology which allows designers and developers to deliver rich internet applications, RIA, embed in web pages. Ado.NET. This is used to create data access layer to query and manipulate data from underlying data source like SQL Server, Oracle, and DB2 etc. Link. This allows you to query the data from the various data sources, like SQL databases, XML documents, Ado.NET datasets, various web services and any other objects such as collections, generics etc., using a SQL query-like syntax with .NET framework languages like C# and VB. Ado.NET Entity Framework. This is used to query and store data into the relational databases, like SQL Server, Oracle, DB2 etc., in ORM fashion. Parallel extension. This allows you to distribute your work code across multiple processors to take advantage of the hardware. WCF. This is used for building and developing services based on WS standards. Asp.NET Web API. Asp.NET Web API is a framework for building HTTP services that can be consumed by a broad range of clients including browsers, mobiles, iPhone and tablets. Signal. ASP. NetSignal is a library that simplifies the process of adding real-time web functionality to applications. Real-time web functionality is the ability to have server code push content to connected clients instantly as it becomes available, rather than having the server wait for a client to request new data. WF. This is used to build process-oriented business workflow and rules engine. Visual Studio 2012. The Visual Studio IDE offers a set of tools that help you to write and modify the code for your programs, and also detect and correct errors in your programs. Using Visual Studio 2012 you can build Windows Store apps, desktop apps, mobile apps, ASP. .NET Web apps, and web services, CLS, Common Language Specification. It is a subset of CTS. All instruction is in CLS, that is, instruction of CTS is written in CLS. Code Manager. Code Manager invokes class loader for execution. .NET supports two kinds of coding. 1. Managed code. 2. Unmanaged code. Managed code. The resource, which is within your application domain, is managed code. The resources that are within domain are FastStore. The code, which is developed in .NET Framework, is known as managed code. This code is directly executed by CLR with help of managed code execution. Any language that is written in .NET Framework is managed code. Managed code uses CLR, which in turn looks after your applications by managing memory, handling security, allowing cross-language debugging, and so on. Unmanaged code. The code, which is developed outside .NET Framework, is known as unmanaged code. Applications that do not run under the control of the CLR are said to be unmanaged, and certain languages such as C++ can be used to write such applications, which, for example, access low-level functions of the operating system. Background compatibility with code of VB, ASP and COM are examples of unmanaged code. Unmanaged code can be unmanaged source code and unmanaged compile code. Unmanaged code is executed with help of wrapper classes. Wrapper classes are of two types, CCW, COM callable wrapper, and RCW, runtime callable wrapper. Wrapper is used to cover difference with the help of CCW and RCW. COM callable wrapper unmanaged code. Native code. The code to be executed must be converted into a language that the target operating system understands, known as native code. This conversion is called compiling code, an act that is performed by a compiler. Under the .NET Framework, however, This is a two-stage process. With help of Mvc and JIT. Mvc, Microsoft Intermediate Language. It is language-independent code. When you compile code that uses the .NET Framework library, you don't immediately create operating system-specific native code. Instead, you compile your code into Microsoft Intermediate Language, MSIL, code. The Mvc code is not specific to any operating system or to any language. JIT, just-in-time. Just-in-time, JIT, compiler, which compiles Mvc into native code that is specific to the OS and machine architecture being targeted. Only at this point can the OS execute the application. The just-in-time part of the name reflects the fact that Mvc code is only compiled as, and when, it is needed. In the past, it was often necessary to compile your code into several applications, each of which targeted a specific operating system and CPU architecture. Often, this was a form of optimization. This is now unnecessary, because JIT compilers, as their name suggests, use Mvc code, which is independent of the machine, operating system, and CPU. Several JIT compilers exist, each targeting a different architecture, and the appropriate one will be used to create the native code required. The beauty of all this is that it requires a lot less work on your part. In fact, you can forget about system-dependent details and concentrate on the more interesting functionality of your code. JIT are of three types: pre-JIT, econo-JIT, normal JIT. Pre-JIT. It converts all the code and executable code, and it is slow. Econo-JIT. It will convert the called executable code only, but it will convert code every time when a code is called again. Normal JIT. It will only convert the called code and will store in cache so that it will not require converting code again. Normal JIT is fast. Assemblies. When you compile an application, the Mvc code created is stored in an assembly. Assemblies include both executable application files that you can run directly from Windows without the need for any other programs. These have a X file extension, and libraries, which have a DLL extension, for use by other applications. In addition to containing Mvc, assemblies also include meta information, that is, information about the information contained in the assembly, also known as metadata, and optional resources, additional data used by the Mvc, such as sound files and pictures. The meta information enables assemblies to be fully self-descriptive. You need no other information to use an assembly, meaning you avoid situations such as failing to add required data to the system registry and so on, which was often a problem when developing with other platforms. This means that deploying applications is often as simple as copying the files into a directory on a remote computer. Because no additional information is required on the target systems, you can just run an executable file from this directory and, assuming the netclr is installed, you're good to go. Of course, you won't necessarily want to include everything required to run an application in one place. You might write some code that performs tasks required by multiple applications. In situations like that, it is often useful to place the reusable code in a place accessible to all applications. In the .NET Framework, this is the Global Assembly Cache, GAC. Placing code in the GAC is simple. You just place the assembly containing the code in the directory containing this cache. Garbage collection, GC. One of the most important features of managed code is the concept of garbage collection. This is the .NET method of making sure that the memory used by an application is freed up completely when the application is no longer in use. Prior to .NET, this was mostly the responsibility of programmers, and a few simple errors in code could result in large blocks of memory mysteriously disappearing as a result of being allocated to the wrong place in memory. That usually meant a progressive slowdown of your computer followed by a system crash. .NET garbage collection works by inspecting the memory of your computer every so often and removing anything from it that is no longer needed. There is no set time frame for this. It might happen thousands of times a second, once every few seconds, or whenever, but you can rest assured that it will happen. We'll try to explain the processing in terms of C# code which is written using Net Framework. Step 1. Application code is written using a Net compatible language C#. Step 2. Code is compiled into Mvc, which is stored in an assembly. Step 3. When this code is executed, either in its own right if it is an executable or when it is used from other code, it must first be compiled into native code using a JIT compiler. Step 4. The native code is executed in the context of the managed CLR, along with any other running applications or processes. One additional point concerning this process. The C# code that compiles into Mvc in Step 2 needn't be contained in a single file. It's possible to split application code across multiple source code files, which are then compiled together into a single assembly. This extremely useful process is known as linking. This is because it is far easier to work with several smaller files than one enormous one. You can separate out logically related code into an individual file so that it can be worked on independently and then practically forgotten about when completed. This also makes it easy to locate specific pieces of code when you need them and enables teams of developers to divide up the programming burden into manageable chunks, whereby individuals can check out pieces of code to work on without risking damage to otherwise satisfactory sections or sections other people are working on. Asp Net Page Lifecycle. When a page is requested, it is loaded into the server memory, processed, and sent to the browser. Then it is unloaded from the memory. At each of these steps, methods and events are available, which could be overridden according to the need of the application. In other words, you can write your own code to override the default code. The page class creates a hierarchical tree of all the controls on the page. All the components on the page, except the directives, are part of this control tree. You can see the control tree by adding trace equals true to the page directive. We will cover page directives and tracing under directives and event handling. The lifecycle starts when a user requests a web page through his/her browser. The web server then processes the page through a sequence of steps before response is sent back to the user's browser. The steps are as: page request, start, page initialization, load, validation, post-back event handling, render, unload. The below figure shows the page lifecycle of an Asp Net and its controls. Page request. The page request occurs before the page lifecycle begins. When a user requests the page, Asp Net determines whether the page needs to be parsed and compiled, therefore beginning the life of a page, or whether a cached version of the page can be sent in response without running the page. Start. In the start step, page properties such as request and response are set. At this stage, the page also determines whether the request is a postback or a new request and sets the isPostback property. Additionally, during the start step, the page's UI culture property is set. Page initialization. During page initialization, controls on the page are available and each control's unique ID are generated but not their properties. Any themes are also applied to the page. Developers have access to the init complete and preload methods in this stage. The methods are as follows. Init. This event is raised after all controls have been initialized and skin settings have been applied. This event is used to read or initialize control properties. Init complete. The page object raises this event. This event is used for processing tasks that require completion of all initialization. Preload. Use this event if you need to perform processing on your page or control before the load event. After the page raises this event, it loads view state for itself and all controls, and then processes any postback data included with the request instance. Load. During load, if the current request is a postback, control properties are loaded with information recovered from view state and control state. The onload event method is fired during this stage. This is where you will want to set properties for all of the server controls on your page, request query strings, and establish database connections. Validation. During validation, the validate method of all validator controls is called, which sets the isValid property of individual validator controls and of the page. Postback event handling. If the request is a postback, any event handlers are called. The event handling for server controls occurs during this stage. Render. During rendering, view state is saved to the page and then the page calls on each control to contribute its rendered output to the output stream of the page's response property. Render is not really an event. The HTML of the page and all controls are sent to the browser for rendering. Unload. Unload is called when the page has been fully rendered, sent to the client, and is ready to be discarded. At this point, page properties such as response and request are unloaded and any cleanup is performed. The cleanup includes routines such as closing database connections and file streams, or event logging and other tasks. When a web page is requested, the server creates objects associated with the page and all of its child controls objects and uses these to render the page to the browser. Once the final stage is complete, the web server destroys these objects, to free up resource to handle additional requests. I hope that this article would have helped you in understanding the page lifecycle in Asp. Net and its controls. When a page is requested, it is loaded into the server memory, processed, and sent to the browser. Then it is unloaded from the memory. At each of these steps, methods and events are available, which could be overridden according to the need of the application. In other words, you can write your own code to override the default code. The page class creates a hierarchical tree of all the controls on the page. All the components on the page, except the directives, are part of this control tree. You can see the control tree by adding trace equals true to the page directive. We will cover page directives and trace under directives and event handling. The page lifecycle phases are: initialization, instantiation of the controls on the page, restoration and maintenance of the state, execution of the event handler codes, page rendering. Understanding the page cycle helps in writing codes for making some specific thing happen at any stage of the page life cycle. It also helps in writing custom controls and initializing them at right time, populate their properties with view state data and run control behavior code. Following are the different stages of an Asp. Net page. Page request. When Asp. Net gets a page request, it decides whether to parse and compile the page, or there would be a cached version of the page. Accordingly, the response is sent. Starting a page life cycle. At this stage, the request and response objects are set. If the request is an old request or postback, the isPostback property of the page is set to true. The UI culture property of the page is also set. Page initialization. At this stage, the controls on the page are assigned unique ID by setting the unique ID property and the themes are applied. For a new request, postback data is loaded and the control properties are restored to the view state values. Page load. At this stage, control properties are set using the view state and control state values. Validation. Validate method of the validation control is called and on its successful execution, the isValid property of the page is set to true. Postback event handling. If the request is a postback, old request, the related event handler is invoked. Page rendering. At this stage, view state for the page and all controls are saved. The page calls the render method for each control and the output of rendering is written to the output stream class of the response property of page. Unload. The rendered page is sent to the client and page properties, such as response and request, are unloaded and all cleanup done. Asp. Net Page Lifecycle events. At each stage of the page lifecycle, the page raises some events, which could be coded. An event handler is basically a function or subroutine, bound to the event, using declarative attributes such as onClick or handle. Following are the page lifecycle events. Pre-init. Pre-init is the first event in page lifecycle. It checks the isPostBack property and determines whether the page is a postback. It sets the themes and master pages, creates dynamic controls, and gets and sets profile property values. This event can be handled by overloading the onPre-init method or creating a page_pre-init handler. Init. Init event initializes the control property and the control tree is built. This event can be handled by overloading the onInit method or creating a page_init handler. Init complete. Init complete event allows tracking of view state. All the controls turn on view state tracking. Load view state. Load view state event allows loading view state information into the controls. Load post data. During this phase, the contents of all the input fields are defined with the form tag are processed. Preload. Reload occurs before the postback data is loaded in the controls. This event can be handled by overloading the onPreload method or creating a page_preload handler. Load. The load event is raised for the page first and then recursively for all child controls. The controls in the control tree are created. This event can be handled by overloading the onLoad method or creating a page_load handler. Load complete. The loading process is completed. Control event handlers are run, and page validation takes place. This event can be handled by overloading the onLoadComplete method or creating a page_loadComplete handler. Pre-render. The pre-render event occurs just before the output is rendered. By handling this event, pages and controls can perform any updates before the output is rendered. Pre-render complete. As the pre-render event is recursively fired for all child controls, this event ensures the completion of the pre-rendering phase. Save state complete. State of control on the page is saved. Personalization. Control state and view state information is saved. The HTML markup is generated. This stage can be handled by overriding the render method or creating a page_render handler. Endload. The unload phase is the last phase of the page lifecycle. It raises the unload event for all controls recursively and lastly for the page itself. Final cleanup is done and all resources and references, such as database connections, are freed. This event can be handled by modifying the onLoad method or creating a page_unload handler. This tutorials cover all the features of ASP.NET Mvc. Why ASP? Net Mvc? Microsoft decided to create their own MVC framework for building web applications. The MVC framework simply builds on top of ASP. Net. When you're building a web application with ASP. Net Mvc, there will be no illusions of state, there will not be such a thing as a page load and no page lifecycle at all, etc. Another design goal for ASP. Net Mvc was to be extensible throughout all aspects of the framework. So when we talk about views, views have to be rendered by a particular type of view engine. The default view engine is still something that can take an ASPX file. But if you don't like using ASPX files, you can use something else and plug in your own view engine. There is a component inside the MVC framework that will instantiate your controllers. You might not like the way that the MVC framework instantiates your controller. You might want to handle that job yourself. So, there are lots of places in MVC where you can inject your own custom logic to handle tasks. The whole idea behind using the model view controller design pattern is that you maintain a separation of concerns. Your control is no longer encumbered with a lot of ties to the ASP. Net runtime or ties to the ASPX page, which is very hard to test. You now just have a class with regular methods on it that you can invoke in unit tests to find out if that controller is going to behave correctly. Benefits of ASP. Net Mvc. Following are the benefits of using ASP. Net Mvc- makes it easier to manage complexity by dividing an application into the model, the view, and the controller. Enables full control over the rendered HTML and provides a clean separation of concerns. Direct control over HTML also means better accessibility for implementing compliance with evolving web standards. facilitates adding more interactivity and responsiveness to existing apps, provides better support for test-driven development, TDD, works well for web applications that are supported by large teams of developers and for web designers who need a high degree of control over the application behavior. This tutorials cover all in this section. You will get an overview of Mvc architecture. The Mvc architectural pattern has existed for a long time in software engineering. Almost all the languages use Mvc with slight variation, but conceptually it remains the same. Let's understand the Mvc architecture in Asp. Net. The features of Asp. Net Mvc. Mvc stands for Model, View, and Controller. Mvc separates application into three components: Model, View, and Controller. Model represents shape of the data and business logic. It maintains the data of the application. Model objects retrieve and store model state in a database. Model is a data and business logic. View is a user interface. View display data using model to the user and also enables them to modify the data. View is a user interface. Controller handles the user request. Typically, user interact with view, which in turn raises appropriate URL request. The request will be handled by controller. The controller renders the appropriate view with the model data as a response. The following figure illustrates the interaction between model, view, and controller. The following figure illustrates the flow of the user's request in Asp. Net Mvc. When the user enters a URL in the browser, it goes to the server and calls appropriate controller. Then, the controller uses the appropriate view and model and creates the response and sends it back to the user. Asp. Net Mvc Lifecycle. At a high level, a lifecycle is simply a series of steps or events used to handle some type of request or to change an application state. You may already be familiar with various framework lifecycles. The concept is not unique to Mvc. For example, the Asp. Net Web Forms platform features a complex page lifecycle. Other net platforms, like Windows Phone apps, have their own application life cycles. One thing that is true for all these platforms regardless of the technology is that understanding the processing pipeline can help you better leverage the features available, and Mvc is no different. Mvc has two life cycles minus the application life cycle, the request life cycle, the application life cycle. The application lifecycle refers to the time at which the application process actually begins running until the time it stops. This is marked by the application start and end events in the startup file of your application. The request lifecycle. It is the sequence of events that happen every time an HTTP request is handled by our application. The entry point for every Mvc application begins with routing. After the Asp. Net platform has received the request, it figures out how it should be handled through the URL routing module. Modules are net components that can hook into the application lifecycle and add functionality. The routing module is responsible for matching the incoming URL to routes that we define in our application. All routes have an associated route handler with them, and this is the entry point to the Mvc framework. The Mvc framework handles converting the route data into a concrete controller that can handle requests. After the controller has been created, the next major step is action execution. A component called the action invoker finds and selects an appropriate action method to invoke the controller. After a action result has been prepared, the next stage triggers, which is result execution. Mvc separates declaring the result from executing the result. If the result is a view type, the view engine will be called and it's responsible for finding and rendering our view. If the result is not a view, the action result will execute on its own. This result execution is what generates an actual response to the original HTTP request. Create first Asp. Net Mvc application. Open a Visual Studio 2013 for web. Click on a new project link in the start page. Alternatively, you can also select File menu, New Project. Expand Visual C# node and select Web in the left pane. Then select Asp. Net Web Application in the middle pane. Name your project. Also, you can change the location of the Mvc application by clicking on Browse button. Finally, click OK. From the new Asp. Net Project dialog, select Mvc as shown below. You can also change the authentication by clicking on Change Authentication button. Wait for some time till Visual Studio creates a simple Mvc project using default template as shown. Press F5 to run the project in debug mode or Ctrl plus F5 to run the project without debugging. Asp. Net Mvc folder structure. We have created our first Mvc 5 application in the previous section. Visual Studio creates the following folder structure for Mvc application by default. App_data. App_data folder can contain application data files like local DB, MDF files, XML files and other data-related files. AS will never serve files from app_data folder. App_start. App_start folder can contain class files which will be executed when the application starts. These would be config files like authconfig.cs, bundleconfig.cs, filterconfig.cs, rootconfig.cs, etc. These would be config files like authconfig.cs, bundleconfig.cs, filterconfig.cs, rootconfig.cs, etc. MVC5 includes bundleconfig.cs, filterconfig.cs and rootconfig.cs by default. Content. Content folder contains static files like CSS files, images and icons files. MVC5 application includes bootstrap.css, bootstrap.min.css and site.css by default. Controllers. Controllers folder contains class files for the controllers. Controllers handles users' request and returns a response. MVC requires the name of all controller files to end with controller. Fonts. Fonts folder contains custom font files for your application. Models. Models folder contains model class files. Typically model class includes public properties, which will be used by application to hold and manipulate application data. Scripts. Scripts folder contains JavaScript or VB script files for the application. M5 includes JavaScript files for Bootstrap, jQuery 1.10 and Modernizer by default. Views. Views folder contains HTML files for the application. Typically view file is a CSHTML file where you write HTML in C# or VB.NET code. Views folder includes separate folder for each controllers. For example, all the CSHTML files, which will be rendered by home controller will be in view home folder. Shared folder under view folder contains all the views which will be shared among different controllers, for example layout files. Global .6, it allows you to write code that runs in response to application level events, such as application_begin request, application_start, application_error, session_start, session_end, etc. Packages.config, this file is managed by NuGet to keep track of what packages and versions you have installed in the application. Web.config, file contains application-level configurations. Routing in MVC. Route defines the URL pattern and handler information. All the configured routes of an application stored in route table and will be used by routing engine to determine appropriate handler class or file for an incoming request. Every MVC application must configure, register, at least one route, which is configured by MVC framework by default. You can register root in root config class, which is in rootconfig.cs under app_start folder. The following figure illustrates how to configure a root in the root config class. The root is configured using the map root extension method of root collection, where name is default, URL pattern is controller, action, id, and defaults parameter for controller, action method and id parameter. Default specifies which controller, action method or value of id parameter should be used if they do not exist in the incoming request URL. The same way, you can configure other roots using map root method of root collection. This root collection is actually a property of root table class. URL pattern. The URL pattern is considered only after domain name part in the URL. For example, the URL pattern, controller, action, id, would look like localhost:1234/controller, action, id. Anything after localhost:1234/ would be considered as controller name. The same way, anything after controller name would be considered as action name and then value of id parameter. If the URL doesn't contain anything after domain name, then the default controller and action method will handle the request. For example, localhost:1234 would be handled by home controller and index method as configured in the defaults parameter. Adding new controller. Now, let's add a new empty controller using Visual Studio 2013 for Web and MVC 5. In the previous section we learned how to create our first MVC application, which in turn created a default home controller. Here, we will create a new student controller. In the Visual Studio, right-click on the controller folder, select Add, click on Controller. Add Scaffold dialog contains different templates to create a new controller. We will learn about other templates later. For now, select MVC5 controller, empty and click Add. In the Add Controller dialog, enter the name of the controller. Remember, controller name must end with controller. Let's enter student controller and click Add. This will create student controller class with index method and student controller.cs file under controllers folder. The student controller class is derived from controller class. Every controller in MVC must derive from this abstract controller class. This base controller class contains helper methods that can be used for various purposes. Now, we will return a dummy string from index action method of above student controller. Changing the return type of index method from action result to string and returning dummy string is shown. We have already seen in the routing section that the URL request localhost web link or localhost web link is handled by the index method of student controller class, shown above. So let's invoke it from the browser and you will see the following page in the browser, action method. In this section, you will learn about the action method of controller class. All the public methods of a controller class are called action methods. They are like any other normal methods with the following restrictions. Action method must be public. It cannot be private or protected. Action method cannot be overloaded. Action method cannot be a static method. The following is an example of index action method of student controller. As you can see in the above figure, index method is a public method and it returns action result using the view method. The view method is defined in the controller base class, which returns the appropriate action result, default action method. Every controller can have default action method as per configured root and root config class. By default, index is a default action method for any controller, as per configured default root. However, you can change the default action name as per your requirement in root config class, action result. MVC framework includes various result classes, which can be returned from an action methods. The result classes represent different types of responses such as HTML, file, string, JSON, JavaScript, etc. The following table lists all the result classes available in Asp Net Mvc. Result class description. View result represents HTML and markup. Empty result represents no response. Content result represents string literal. File content result / file path result / file stream result represents the content of a file. JavaScript result represent a JavaScript script. JSON result represent JSON that can be used in Ajax. Redirect result represents a redirection to a new URL. Redirect to root result represent another action of same or other controller. Partial view result returns HTML from partial view. HTTP unauthorized result returns HTTP 403 status. The action result class is a base class of all the above result classes, so it can be return type of action methods which returns any type of result listed above. However, you can specify appropriate result class as a return type of action method. The index method of student controller in the above figure uses view method to return view result, which is derived from action result. The view method is defined in base controller class. It also contains different methods, which automatically returns particular type of result. Result class description base controller method. View result represents HTML and markup. View. Empty result represents no response. Content result represents string literal. Content. File content result. File path result. File stream result represents the content of a file. JavaScript result represent a JavaScript script. JavaScript. JSON result represent JSON that can be used in Ajax JSON. Redirect result represents a redirection to a new URL redirect. Redirect to root result represent another action of same or other controller redirect to root. Partial view result returns HTML partial view. HTTP unauthorized result returns HTTP 403 status. As you can see in the above table, view method returns view result, content method returns string, file method returns content of a file and so on. Use different methods mentioned in the above table to return different types of results from an action method. Action method parameters. Every action methods can have input parameters as normal methods. It can be primitive data type or complex type parameters as shown. By default, the values for action method parameters are retrieved from the requests data collection. The data collection includes name, values pairs for form data or query string values or cookie values. Model binding in Asp. Net Mvc automatically maps the URL query string or form data collection to the action method parameters if both names are matching. Visit Model Binding section for more information on it. Action Selectors. Action Selector is the attribute that can be applied to the action methods. It helps the routing engine to select the correct action method to handle a particular request. MVC 5 includes the following action selector attributes. Action name. Non-action. Action verbs. Action name. Action name attribute allows us to specify a different action name than the method name. Consider the following example. In the above example, we have applied Actio name find attribute to get by id action method. So now, action name is find instead of get by id. This action method will be invoked on localhost web link request instead of localhost web link request. Non-action. Non-action selector attribute indicates that a public method of a controller is not an action method. Use non-action attribute when you want public method in a controller but do not want to treat it as an action method. For example, the getStudent public method cannot be invoked in the same way as action method in the following example. Action verbs. In this section, you will learn about the action verbs selectors attribute. The action verbs selector is used when you want to control the selection of an action method based on a HTTP request method. For example, you can define two different action methods with the same name but one action method responds to an HTTP GET request and another action method responds to an HTTP POST request. MVC framework supports different action verbs, such as HTTP GET, HTTP POST, HTTP PUT, HTTP DELETE, HTTP OPTIONS, and HTTP PATCH. You can apply these attributes to action method to indicate the kind of HTTP request that the action method supports. If you do not apply any attribute, then it considers it a GET request by default. The following table lists the usage of HTTP methods. HTTP method usage. GET to retrieve the information from the server. Parameters will be appended in the query string. POST to create a new resource. PUT to update an existing resource. Head identical to GET except that server do not return message body. Options method represents a request for information about the communication options supported by web server. Delete to delete an existing resource. Patch to full or partial update the resource. Visit w3.org for more information on HTTP methods. You can also apply multiple HTTP verbs using except verbs attribute. Get and post action method supports both get and post action verbs. Points to remember. Action verbs are another action selectors which selects an action method based on request methods e.g post, get, put, etc. Multiple action methods can have same name with different action verbs. Method overloading rules are applicable. Multiple action verbs can be applied to a single action method using except verbs attribute. Model in Asp. Net Mvc. Model represents domain-specific data and business logic in Mvc architecture. It maintains the data of the application. Model objects retrieve and store model state in the persistence store like a database. Model class holds data in public property. All the model classes reside in the model folder in Mvc folder structure. Let's see how to add model class in Asp. Net Mvc. Adding model. Open our first Mvc project created in previous step in the Visual Studio. Right-click on Model folder, Add, click on Class. In the Add New Item dialog box, enter class name student and click Add. This will add new student class in Model folder. Now, add id, name, age properties as shown. So in this way, you can create a model class which you can use in Vue. You will learn how to implement validations using model later. View in Asp. Net Mvc. We have already created student controller and student model in the previous section. Now, let's create a student view and understand how to use model into Vue. We will create a view, which will be rendered from index method of student controller. So, open a student controller class, right-click inside index method, click Add View. In the Add View dialog box, keep the view name as index. It's good practice to keep the view name the same as the action method name so that you don't have to specify view name explicitly in the action method while returning the view. Select the scaffolding template. Template drop-down will show default templates available for create, delete, details, edit, list or empty view. Select list template because we want to show list of students in the view. Now, select student from the model class drop-down. Model class drop-down automatically displays the name of all the classes in the model folder. We have already created student model class in the previous section, so it would be included in the drop-down. Use a layout page checkbox and select _layout.cshtml page for this view and then click Add button. We will see later what is layout page, but for now think it like a master page in Mvc. This will create index view under view, student folder as shown. The following code snippet shows an index.cshtml. As you can see in the above index view, it contains both HTML and Razor codes. Inline Razor expression starts with that symbol. @HTML is a helper class to generate HTML controls. You will learn Razor syntax and HTML helpers in the coming sections. The above index view will look like these. Integrate controller, view and model. We have already created student controller, model and view in the previous sections, but we have not integrated all these components in order to run it. The following code snippet shows student controller and student model class and view created in the previous sections. Now, to run it successfully, we need to pass a model object from controller to index view. As you can see in the above index.cshtml, it uses enumerable of student as a model object. So we need to pass enumerable of student model from the index action method of student controller class as shown below. As you can see in the above code, we have created a list of student objects for an example purpose. In real-life application, you can fetch it from the database. We then pass this list object as a parameter in the view method. The view method is defined in base controller class, which automatically binds model object to the view. Now, you can run the Mvc project by pressing F5 and navigate to local Asp web link. You will see following view in the browser. Learn how to integrate model, view and controller in the next section. See you soon. Bye. Thank you.